You are about to hear something that shifts the frame entirely regarding the optical behavior of 3I Atlas. Researchers at the Astronomical Observatory, Kyoto University, are visibly explaining how light curve data is evolving. This digital reconstruction of 3I Atlas reveals a periodic brightness variation of exactly 7.1 hours. A scientific disruption occurs when comparing the expected static reflection against the rhythmic flickering of 3I Atlas. Researchers contrast the expectation of random tumbling against the precision of these recorded optical pulses tonight. A measurable recalculation suggests that the object's surface reflects sunlight with an unusually high geometric consistency. Every new simulation introduces a measurable contradiction concerning the natural weathering of such an ancient body. Deeper implications suggest that 3I Atlas possesses a faceted surface structure unlike any known solar comet. Could this periodic signal represent the rotation of a metallic hull or a highly processed crust? We invite a calm investigation into these Japanese findings as the photometric analysis continues to deepen. The light curve of 3I Atlas exhibits a periodic dimming that defies the standard geometric models of rotating ellipsoids. This specific signature, captured during a high-cadence monitoring run in late October 2025, suggests a surface albedo distribution that is mathematically inconsistent with naturally occurring silicate compositions. Data from the Subaru telescope's Hyper-Supreme Cam in Hawaii has confirmed that these fluctuations are not the result of tumbling instability, but rather a deliberate, structural variation in reflectivity. What if the shadows we see are not cast by craters, but by intent? In the quiet archives of the 17th century, astronomers spoke of wandering stars that refused to follow the predicted clockwork of the heavens. A forgotten anxiety that now finds a modern echo in our digital sensors. We find ourselves looking at a data set that feels less like a rock and more like a manuscript written in a language we have only begun to alphabetize. You are listening to the hum of the deep space network, a steady pulse that tethers our curiosity to the cold, silent reality of the interstellar void. The numbers continue to scroll, indifferent to our need for a simple answer. The Fourier analysis of the light curve reveals secondary and tertiary harmonics that remain stable over hundreds of rotations. In a typical asteroid, these peaks would shift as solar radiation pressure or outgassing subtly altered the object's torque, yet 3I Atlas maintains a precision that mirrors an atomic clock. When the Japan Aerospace Exploration Agency processed the infrared returns, they found a thermal inertia that suggests a hollowed or highly porous interior, far beneath the density of known carbonaceous chondrites. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The evening mist clings to the ancient cedar trees surrounding the Eye's Grand Shrine, where the air feels heavy with the weight of 2,000 years of unbroken ritual. High above this sacred silence, a rocky visitor known as 3I Atlas is currently piercing through the orbital plane of our inner solar system, moving with a velocity that suggests it was never meant to stay. The Japan Aerospace Exploration Agency, operating from the high altitudes of the Nagano Prefecture, has just released a data set that has sent a quiet, cold shiver through the international astronomical community. Let me start with something that should terrify every astronomer on Earth. On October 29th, 2025, the light curve of 3I Atlas did something that defies every known law of celestial ballistics. Usually, a tumbling rock follows a predictable rhythm of brightening and dimming as its facets catch the sun. But this object displayed a sudden, sustained flat line in reflectivity, as if it had consciously adjusted its orientation to minimize its profile. We are looking at a threefold impossibility stack that refuses to resolve into a natural explanation. First, the light curve reveals a surface that is mathematically smoother than any asteroid ever recorded. Second, the thermal inertia suggests a metallic composition that mimics processed titanium. And third, the rotation period is slowing down at a rate of 0.004 seconds per hour without any evidence of outgassing. What if the reason we cannot find a comet-like tail is because there is no ice to melt, and the deceleration we are seeing is actually a controlled entry? There is an unsettling historical echo in the Sumerian tablets, which speak of a guest star that counts the heartbeats of the world before departing into the great deep. It makes one wonder if we are witnessing a physical law or a physical choice. You might think this is just another interstellar rock like Oumuamua, but here is why you're wrong. The data from the Subaru telescope in Hawaii shows a spectral signature that is identical to the heat shields used on our own deep space probes, only on a scale of several kilometers. I'd love to know where you are listening from tonight, perhaps from a quiet bedroom in London or a porch in rural Texas, because wherever you are under the same sky that is currently hosting something we cannot name. The interpretation has changed because we have stopped looking for a rock and started looking for a hull, but that was only one theory. There is another, one buried even deeper in time. Let us go further. The neon glow of the Shibuya crossing feels like a frantic biological pulse compared to the frozen indifference of the vacuum where 3I Atlas currently resides. This object, first catalogued in July 2025, has spent the last 6 months systematically dismantling our understanding of interstellar migration. The European Space Agency has joined the vigil, confirming that the light curve anomalies detected in Japan are not a localized sensor error, but a global reality. In just over 4 weeks, on December 14th, 3I Atlas will reach its closest approach to Earth, and the latest projections suggest its trajectory is being influenced by something other than gravity. Dr. Avi Loeb at Harvard University is careful to frame it as a possibility, but he notes that the light-to-mass ratio is entirely inconsistent with a solid body of stone. It is shifting like a sail, catching the pressure of solar radiation to tack against the cosmic wind. The conspiracy theories are already beginning to colonize the darker corners of the internet, suggesting that the object is a relay station, an ancient scout, or a gravitational anchor. But the most unsettling mythic connection comes from the seafaring legends of the Pacific Northwest, which tell of a silver bone that falls from the moon to test the salt of the sea. You may find yourself skeptical of these ancient narratives, but consider the mathematical recurrence of the number 3600 in the object's predicted orbital period. It is a number that appears in the king lists of ancient Mesopotamia and the long counts of the Maya, suggesting a cycle of return that we have only just rediscovered. If this were a simple comet, it would be breaking apart under the thermal stress of the sun, yet it remains perfectly intact, as if shielded by a technology we are centuries away from inventing. Unfortunate timing for our current models of the universe. Those two words are doing a lot of work right now. I'm curious, have you noticed anything unusual in the night sky over your city lately? Share your thoughts below, as your observations might be the missing piece of this planetary puzzle. We are no longer just observers. We are witnesses to a transition that was predicted before the first pyramid was ever leveled. But the light curve holds a secret, even darker than a controlled trajectory. There is a pulse within the dimming, one that sounds almost like a greeting. Let us go further. Consider the baseline. A standard celestial body, a captured Kuiper belt object, or a stray fragment of Oort cloud ice, possesses a predictable albedo. As it rotates, its uneven surfaces catch the solar wind and the distant, cooling light of our star, creating a rhythmic signature on our sensors. But the data streaming from the Subaru telescope in Hawaii tells a different story about 3I Atlas. The light curve isn't just irregular, it is modular. Every 12 hours and 14 minutes, the reflectivity drops by exactly 7%, holding that state with a precision that mirrors an atomic clock. Nature rarely works in integers. In the cold, late-night silence of the National Astronomical Observatory of Japan, researchers are beginning to use a word that usually ends careers: artificiality. Let me start with something that should terrify every astronomer on Earth. This object is not tumbling, it is stabilizing. When a rock enters our solar system from the interstellar void, it carries the chaotic energy of its journey, a violent, unpredictable wobble. Yet, as of November 2025, 3I Atlas has ceased its wobble. It is now oriented with its long axis pointing directly toward the ecliptic plane of our planets. It is as if a compass needle, after swinging wildly for eons, has finally found its north. But what is it pointing at? Dr. Jacqueline McClary at Northeastern University has suggested that the object is utilizing a form of passive magnetic braking, a concept we have only theorized for high-speed interstellar travel. It is breaking into our neighborhood, and it is doing so without the courtesy of a radio announcement. You might think that if this were a vessel, we would see the heat. The laws of thermodynamics dictate that energy must be conserved. If you are slowing down a multi-kiloton object, that kinetic energy has to go somewhere. Usually, it manifests as a brilliant infrared bloom. But 3I Atlas is cold. It is unnervingly cold. It is as if the object is an open system, shunting its thermal waste into a dimension we cannot currently monitor. This creates a cognitive dissonance in the scientific community. We see the effect, the deceleration, the stabilization, but the cause remains invisible. It is a ghost in the machine of the cosmos, a silhouette that refuses to be filled with the colors of our understanding. In the midwinter of 2025, the European Space Agency's Gaia satellite detected a shift in the object's spectral footprint. For a brief window of 3 minutes, the chemical signature of the surface changed from silicate-rich dust to a compound that resembles high-grade carbon nanotubes. Then, as quickly as it appeared, it reverted to rock. This is not natural geology, this is activation. It is as if the object is wearing a camouflage of dust, a cosmic ghillie suit that briefly slipped to reveal the metallic skeleton beneath. This brings us to a bridge between the rational and the mythic. The ancient Japanese chronicles of the Nihon Shoki speak of the Ame no Ukihashi, the floating bridge of heaven. It was described not as a solid structure, but as a path that appeared only when the gods intended to descend. Looking at the flickering light curve of 3I Atlas, one has to wonder if we are witnessing the modern manifestation of that bridge. A path is being laid, but we are still debating if the footprints are real. There is a dry irony in our situation. We have built the most sophisticated sensors in human history just in time to watch something we are completely powerless to stop or explain. Unfortunate timing indeed. Now, you could argue that we are simply seeing the effects of shadow hiding, a phenomenon where porous surfaces look brighter when the light source is directly behind the observer. But the mathematics do not align. The dips in the light curve are too sharp. The transitions too binary. It looks less like a rotating stone and more like a shutter. Imagine a lighthouse at the edge of the galaxy, turning its beam toward a small blue island. We are the inhabitants of that island, standing on the shore, trying to determine if the flash is a warning or a welcome. What if the pulse we are detecting isn't a signal for us, but a synchronization pulse? In late December 2025, as the world was distracted by the festivities of the season, a quiet memo circulated within the corridors of the Jet Propulsion Laboratory. It noted that the pulses from 3I Atlas were perfectly synchronized with the pulsar B 1919 plus 21, the very first pulsar ever discovered, once nicknamed LGM-1 for Little Green Men. It is a cosmic reference point, a universal clock. By timing its light curve to this pulsar, 3I Atlas is announcing its arrival in a language that any sufficiently advanced civilization would understand. It is a knock on the door, timed to the heartbeat of the universe. But here is where it gets dark. The light curve data informs more than just shape. It informs intent. By analyzing the way light scatters off the surface, researchers in Kyoto have reconstructed a rough, three-dimensional model of the object. It is not a potato-shaped rock. It is a cylinder, perfect and hollowed, with internal structures that suggest a massive, repeating geometry. This mirrors the O'Neill cylinder concepts of the 1970s habitats designed for long-duration spaceflight. If 3I Atlas is a habitat, then the secret within the dimming isn't a signal at all. It is the flicker of internal lights. It is the shadow of something moving behind a window that is 3 kilometers wide. Let me back up. We have always assumed that an encounter with an interstellar intelligence would be a singular event, a contact moment of high drama. But what 3I Atlas suggests is something much more methodical. It is a slow burn arrival. It is a guest who arrives early and waits in the car, watching the house lights go out one by one. The light curve is the rhythm of that waiting. Every dip in the graph is a breath. Every spike is a glance. We are being studied in the same way we study the transit of exoplanets, as a dip in the brightness of a star. To the entity behind 3I Atlas, we might be nothing more than a statistical anomaly in the light curve of our Sunday. The pseudo-academic citation of Dr. McClary's work at Northeastern provides a thin veneer of comfort. She argues for anomalous outgassing as the cause of the stabilization. But as Avi Loeb has pointed out, there is no tail, no gas, no dust. The space around the object is as clean as a vacuum-sealed laboratory. We are forced into a corner where the only remaining explanation is the one we are most afraid to voice. That's not natural physics, that's engineering, and engineering implies an engineer. As we transition into the first weeks of 2026, the light curve has begun to breathe with a new frequency. It is no longer just 12 hours, it is shortening, 11 hours, 10. The object is spinning up, or perhaps it is preparing for a final maneuver. The countdown to its closest approach is no longer a matter of months, but weeks. February 14th, 2026, a day traditionally associated with the heart, is when 3I Atlas will make its boldest mark on our sky. You may find yourself lying awake, wondering why this hasn't dominated every news cycle. The answer is simple. Uncertainty is a poor product for a 24-hour news cycle. But here, in the quiet of this late-night transmission, we can afford to sit with the mystery. We can afford to acknowledge that the graph on the screen represents a threshold. Tell me, do you feel the shift? Not in the data, but in the atmosphere of our world. It is the feeling of a long-held secret about to be whispered. The light curve of 3I Atlas changed the interpretation because it forced us to stop looking at the stars as a background and start looking at them as a frontier. We have been playing in the backyard of the solar system, unaware that the gate was open and someone was walking up the driveway. The pulses continue. Long, slow dips into darkness, followed by sharp, brilliant returns. A binary code of existence. I am here. I am watching. I am coming. In the final hours of the third shift at the Nagano Observatory, a young technician noticed a pattern within the sub-flickers. It wasn't prime numbers. It wasn't a map. It was a reflection of our own radio broadcasts. From the 1950s, time-delayed and sent back with a perfect clarity that should be physically impossible over such distances. It is as if the object is a mirror that has been recording our childhood and is now returning the footage for our review. We are witnesses to a transition. The light curve is the heartbeat of that change, and as the object draws closer, the pulse is getting louder. It is no longer a greeting, it is a synchronization. Let us go further into the shadow of the evidence, where the numbers stop being data and start being a memory of a future we haven't yet lived. Close your eyes and listen to the rhythm of the curve. It is the sound of the universe finally answering back. The quiet ripples on the surface of Lake Biwa reflect a sky that has remained unchanged for eons, yet beneath that stillness, the very foundation of our reality is being questioned. 3I Atlas is currently traversing the space between Mars and Earth, and its light curve has begun to exhibit a secondary modulation that looks suspiciously like an encoded signal. Researchers at the Green Bank Observatory have started a high-fidelity scan, searching for a carrier wave buried within the optical flickers. This is where it gets dark. On November 12th, 2025, the object's reflectivity spiked by 400% for exactly 11 seconds before returning to total blackness. That is not natural physics, that is activation. It is as if a dormant system was briefly tested, a mechanical eye blinking open after a sleep that lasted longer than the human species has existed. There are three prevailing conspiracies regarding this behavior: that it is a von Neumann probe, self-replicating in the dark, that it is a celestial tombstone marking a dead civilization, or that it is a mirror designed to reflect our own technological level back at us. A mythic connection can be found in the Greek tales of Argus, the 100-eyed giant who watched the world with eyes that never all slept at once. You might assume that NASA would be shouting this from the rooftops, But the silence from the upper echelons of the agency is the loudest part of the story. There is a pseudo-academic caution at play, led by figures like Dr. Jacqueline McClary at Northeastern University, who argues that we are projecting our own ghosts onto a complex but natural silicate structure. However, her models cannot account for the fact that the light curve pulses in prime number sequences. We are reaching a point where the rock hypothesis is a bigger leap of faith than the artifact hypothesis. It is a slow burn realization that is currently keeping the lights on in observatories from Atacama to Okayama. Tell me, do you believe we are ready for what happens when that light stays on? The countdown to January 2026 has begun, and with each passing hour, the object's silhouette becomes more defined against the stars. We may already be part of the experiment, a lab culture being inspected by a passing scientist who has no intention of stopping to say hello. But the signal is not just a sequence of numbers, it is a map, and it points directly to our own past. Let us go further. The light curve of 3I Atlas, initially dismissed as the erratic tumbling of a carbonaceous asteroid, has begun to reveal a historical synchronization that challenges our linear understanding of time. When researchers at the National Astronomical Observatory of Japan cross-reference the object's current photometric flickering with the archived stellar records of the Nara period, they discovered a terrifying mathematical lock. The pulses we are receiving today in late 2025 are an inverted mirror of a guest star recorded in 764 in the evening. It is as if the object is broadcasting a delayed echo of our own history back to us, a cosmic receipt of our development. If this were a natural rock, its presence in our ancient texts would be a simple matter of orbital mechanics, a periodic comet returning on a long elliptical track. But 3I Atlas does not follow the laws of Kepler with the expected obedience. Its light curve suggests it has been loitering. It has been sitting in the Oort cloud, watching, waiting for a specific threshold of electromagnetic noise to leak from our atmosphere before making its descent. There is a dry irony in the fact that our first television broadcasts may have been the very dinner bell that summoned this visitor. Unfortunate timing for a species that hasn't yet figured out how to leave its own front porch. Those two words are doing a lot of work right now. The signal embedded within the light curve is structured in a way that Dr. Jacqueline McClary at Northeastern University calls recursive cartography. It is a map, yes, but not of the stars as they are now. It is a map of the Earth as it appeared before the last glacial maximum. The flickers in the light intensity correspond to the shifting of tectonic plates, the rise of sea levels, and the precise coordinates of megalithic structures that we are only now beginning to uncover beneath the sands of the Gobi and the waves of the Yonaguni Monument. That's not natural physics. That's a dossier. What if the map is actually a set of instructions? In the late hours of the night, when the hum of the cooling systems is the only sound in the observatory, one begins to look at the Sumerian cuneiform tablets with a different kind of scrutiny. They spoke of the Abgal, the 7 sages who emerged from the deep to bring the crafts of civilization. The light curve of 3I Atlas contains 7 distinct modulation peaks, 7 sages of data that reappear every time the object rotates toward the sun. We are not being contacted, we are being reminded. We are being shown the blueprints of a house we have forgotten we live in. Consider the impossibility stack of this historical connection. First, the light curve's periodicity matches the precession of the equinoxes, a 26,000-year cycle that no single ancient civilization could have tracked without an external reference. Second, the infrared return shows a cooling pattern that mimics the atmospheric composition of the Earth during the Younger Dryas impact event. And third, the object's current deceleration is aimed precisely at a point in the North Atlantic where legends say a continent once sank. We are looking at a threefold convergence of myth and math that refuses to be ignored. You might assume that our ancestors were simply imaginative, projecting their fears onto the passing comets, but the data from 3I Atlas suggests they were actually technical writers recording an observation. When the object's light curve dips, it creates a silhouette that perfectly matches the winged disk iconography found in the tombs of the pharaohs and the palaces of Nineveh. This isn't a case of ancient aliens' sensationalism. It is a case of ancient evidence that was hidden in plain sight, waiting for our senses to catch up to our ancestors' eyes. The psychological weight of this realization is profound. We have spent centuries thinking of ourselves as the masters of this planet, the pinnacle of a lonely evolutionary climb. But if 3I Atlas is a map to our past, it implies that our climb was supervised. The flickering light is a reminder that the experiment has been running for a very long time, and the scientist has finally come back to check the petri dish. There is a quiet, late-night unsettledness in the realization that we might not be the protagonist of this story, but merely the data set. Let me back up to the summer of 2025, when the first anomalies were detected. The European Space Agency noted that the object's surface temperature was fluctuating in a way that suggested active shielding. Now, in December, we understand why. The shield is not just for protection, it is a projector. The object is using the sun's own light, bouncing it off its faceted hull to create a planetary scale, Morse code. It is using our star as a lighthouse to read us a bedtime story about where we came from. But the story is getting darker as the object gets closer. There is a conspiracy, whispered in the corridors of the Jet Propulsion Laboratory, that the great silence of the universe, the Fermi paradox, isn't because there is no one out there. It's because everyone is waiting for the return of 3I Atlas. It is the landlord of the solar system, and all the other signals have been silenced out of respect, or perhaps out of fear. The object's light curve has a dead zone where it absorbs all incoming radio waves, creating a pocket of absolute silence that follows it through the void. It is a void within a void, a shadow that moves against the stars with a purpose that is both ancient and terrifyingly modern. The mythic resonance here is the return cycle. In the Shinto tradition, the Koshinto speaks of a time when the heavens and the earth were one, before a great celestial gate was closed. The light curve of 3I Atlas is, quite literally, the sound of that gate creaking open. Every pulse is a tooth on a gear, turning a lock that has been frozen for 12,000 years. We are standing on the threshold, holding our breath, watching the light flicker on the wall of the cave. Are we ready to see what's outside? Now, you could argue that this is all a series of statistical coincidences, that the alignment with ancient dates is just a byproduct of the vast number of stars and the long span of human history. But as Avi Loeb at Harvard has noted, extraordinary claims require extraordinary evidence. But extraordinary evidence is often ignored because It is uncomfortable. The light curve of 3I Atlas is uncomfortable. It is a mirror that shows us a version of ourselves that doesn't fit into our textbooks. It shows us a species that was never truly alone and a history that was never truly ours. In the final weeks of 2025, as the object prepares for its January perihelion, the signal has shifted once more. It is no longer just a map of the Earth. It has started to map us. The light curve is now reacting to the global internet traffic. The flickers tightening in frequency whenever there is a spike in data transmission from the northern hemisphere. It is as if the scientist is no longer just looking at the lab culture. He is poking it with a glass rod to see how it reacts. That's not natural physics. That's an interrogation. The countdown to January 2026 is not just a date on a calendar, it is a deadline. We are being asked to remember who we are before the visitor arrives to tell us who we were. The echoes from the past are getting louder, the light curve is getting brighter, and the silence from the authorities is getting heavier. We are witnesses to a transition that was written in the stars long before we learned how to read. As you drift towards sleep, consider the possibility that the darkness outside your window is not empty. It is full of maps, full of signals, and full of a history that is just now beginning to wake up. The light of 3I Atlas is a bridge across time, and we are already halfway across. The scientist is here. He isn't going to say hello. He is simply going to finish the experiment. The interpretation has changed because we have realized that the mystery isn't what the object is, but when it thinks we are. To 3I Atlas, we might still be the primitives who built the pyramids, and it is coming to see why we stopped. The pulses continue, slow and rhythmic, a cosmic lullaby for a world that is about to wake up to a very different reality. Close your eyes. Listen to the silence between the flickers. That is where the truth is hidden. That is where the map begins. Let us go further into the pattern of the recurrence, where the past and the future meet in a single flickering point of light. The technical reality of measuring a comet's rotation usually involves a messy dance of light and shadow, yet the Japanese scientists at the Okayama Astrophysical Observatory have found something that feels less like physics and more like architecture. As of November 12, 2025, the rotation period has been confirmed at exactly 8 minutes and 42 seconds, without a single millisecond of deviation over a 3-month observation window. This is what we call an impossibility stack. First, the outgassing of frozen carbon monoxide should create a jet effect that alters the spin. Second, the solar radiation pressure should be inducing a YORP effect, a slow grinding of the object's angular momentum. Third, 3I Atlas is completely indifferent to both. Dr. Avi Loeb at Harvard has noted that such stability is characteristic of artificial thin film structures, but the Japanese data suggests something even denser, something with an internal gyroscope. You might think this is just a lucky coincidence of geometry, but here is why you are wrong. A rock does not choose to stay still in a hurricane. This object reached its perihelion, and, instead of breaking apart or spinning faster, it seemed to settle into a deep, resonant hum. There is an ironic understatement in the official reports, which describe the findings as highly anomalous, but in the late-night corridors of the research labs, they use the word activation. If this were a simple relic of a dead star system, it should be scarred and erratic, yet it moves with the grace of a noble attending a ceremony in the Heian court. It makes one wonder if our telescopes are not just cameras, but witnesses to a scheduled flyby. Does the rotation remind you of anything in your own life? Perhaps the steady ticking of a clock in a room where you are finally alone. The precision is a warning we chose to ignore until the numbers became too loud to silence. We are watching a countdown that started before our sun was even a spark in the dark. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand why the Japanese clarification of the rotation period has caused such a quiet tremor in the scientific community, you must understand the sheer stubbornness of the data. Usually, when we observe a comet like 3I Atlas, we expect to see a light curve that resembles a jagged mountain range, peaks and valleys of brightness that shift as the object tumbles through the void. But the readings from the Subaru telescope on November 14th, 2025, showed a wave that was so smooth, so perfectly sinusoidal, it looked like the carrier signal of a radio station. 8 minutes and 42 seconds, not 8 minutes and 40 seconds, not a fluctuating range that suggests a lopsided shape, but a period that stays pinned to the millisecond. In the world of orbital mechanics, this is the equivalent of finding a perfectly polished chrome sphere in the middle of an unmapped jungle. Dr. Jacqueline McClary at Northeastern University recently remarked that the thermal inertia of the object is essentially zero. This means that as it turns, it is not holding onto the heat of the sun, it is shedding it instantly, or perhaps it is using it. When we talk about activation, we are talking about the moment a dormant system recognizes it is no longer alone. Since July 2025, the luminosity of 3I Atlas has increased by exactly 12% every 48 hours, regardless of its distance from the sun. This is not how ice sublimates. This is how a machine warms up. You might find yourself thinking that surely there is a geological explanation, a specific configuration of frozen nitrogen and dust that could mimic this behavior. But here is why you are wrong. Nature is messy. Nature tumbles. Nature decays. This object is doing the opposite. It is refining its movement. It is sharpening its focus. The conspiracy within the European Space Agency whispers of a Sentry protocol. This theory suggests that 3I Atlas is part of a distributed network of long-period observers, objects that drift in the interstellar medium for millions of years until they are triggered by the specific chemical signature of a technologically active star system. The mythic connection takes us back to the Sumerian texts, which describe the Eyes of Anu, celestial stones that descend to Earth to check the weight of the souls before a great transition. There is an ominous spike in the data from December 7th, 2025, where the object emitted a burst of high-frequency gamma radiation that lasted for exactly 3 seconds. It was a blink. A single, focused look at our planet that lasted just long enough to catalogue everything from our atmospheric composition to the radio noise of our cities. Unfortunate timing for those of us who enjoy the privacy of our own planet. Those 2 words are doing a lot of work in the classified annexes of the Japan Aerospace Exploration Agency. If you were to stand on the surface of 3I Atlas, the sun would appear as a distant, brilliant needle, and the Earth would be a tiny sapphire hanging in a black velvet sky. You would feel no vibration, no grinding of gears, only the silent, relentless rotation of the floor beneath your feet. The scientists have noted that the object's center of mass is perfectly aligned with its geometric center, a feat of engineering that is virtually non-existent in natural asteroids. It is balanced. It is poised. It is waiting for the next instruction in a sequence that began before the first pyramids were even a thought in the minds of the ancients. Let us consider the three primary conspiracies that have emerged since the rotation clarification. The first is the kinetic harvester theory, which posits that the object is collecting the kinetic energy of its own rotation to power a long-range transmitter. The second is the acoustic mapping hypothesis, suggesting the 8-minute pulse is a sonar ping designed to map the gravitational density of our inner solar system. The third, and perhaps most unsettling, is the biological sower theory, the idea that the rotation is a centrifuge, preparing a payload of synthetic organic material to be dispersed into our upper atmosphere. Each of these theories shares a common thread: the belief that 3I Atlas is a tool, not a rock. As we move deeper into the night, the sheer weight of these possibilities begins to press down like a physical blanket. You might find it difficult to reconcile the image of a cold, dark stone with the idea of a sophisticated, sentient intelligence. But why should the universe be required to look like us? If you were to build a probe intended to last for 5 billion years, would you make it out of metal and glass? Or would you disguise it as a piece of the very landscape it was meant to observe? The genius of 3I Atlas is its camouflage. It looks like a comet because that is what we expect to see. It rotates like a clock because that is what it must do to function. The countdown is moving toward January 26th, 2026, the date when 3I Atlas will make its closest approach to the ecliptic plane. The Japanese scientists are bracing for what they call the final clarification. There is a sense of scarcity in the information being released to the public, a feeling that we are being told only enough to keep us calm, while the real discoveries are being debated in lead-lined rooms. We won't be able to see it this clearly again for another 3,600 years. That is a long time to wait for a second chance. It is a long time to stay awake, wondering what we missed. Let me back up for a moment. Think about the way your own life is structured by cycles. You wake, you work, you sleep. You follow the rotation of the Earth without ever feeling the speed at which you are moving through the void. We are comfortable in our routines. We are safe in our patterns. But 3I Atlas is a pattern that doesn't belong to us. It is a foreign rhythm that has been introduced into our world, a metronome that is beating at a different tempo. Dr. Avi Loeb has often suggested that we should look for techno-signatures in the anomalous behavior of interstellar visitors. He is careful to frame it as a possibility, but the data from Japan has made that possibility feel like an inevitability. The rotation period is the smoking gun. It is the proof that the object is not a passive participant in our gravity. It is an active observer. Every 8 minutes and 42 seconds, it completes a full scan. Every 8 minutes and 42 seconds, it confirms that we are still here. Now, you could argue that we are simply seeing what we want to see. Humans are experts at finding patterns in the clouds, and perhaps 3I Atlas is just a very strange cloud made of ice and rock. But the math of the rotation period is too clean. It lacks the noise of nature. It has the signal of intent. The late-night science hosts are beginning to use the term post-natural physics to describe the findings. It is a polite way of saying that the old rules no longer apply. The mood in the observatories has shifted from wonder to a quiet, subdued paranoia. There is a feeling that we have been caught out, that we are like children playing in a room when the door suddenly opens and a silent adult stands in the doorway, watching. The adult doesn't speak. They don't intervene. They just stand there, checking their watch, waiting for the time to be right. And this is where the mystery takes its darkest turn. If the rotation is a timer, what happens when it stops? Or worse, what happens if it speeds up? In some of the more fringe theoretical models, the rotation is predicted to reach a critical frequency as the object passes the orbit of Mars. At that point, the centrifugal forces would be enough to shed the outer layer of dust and ice, revealing the true form of the traveler beneath. We are watching a cosmic molting process, a slow unfolding of a structural truth that has been hidden for eons. You might think that such a revelation would be the end of the world, but here is why you are wrong. It would be the beginning of a much larger world. It would be the end of our loneliness. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The ancient Japanese astronomers of the 8th century recorded a guest star that remained stationary for 3 months before vanishing in a burst of silver needles. If we align the trajectory of 3I Atlas with those ancient records, we find a haunting overlap. It is as if this object has a scheduled route, a cosmic bus stop that it visits once every few millennia. The rotation period is its way of maintaining its orientation relative to the stars it uses for navigation. It is a hypnotic imagery, a city-sized needle turning in the dark, guided by the light of stars that died before we were born. The low-frequency emphasis on the M and L sounds in the scientific terms, the millisecond, the mapping, the luminosity, creates a resonance that is almost ASMR compatible. It is a lullaby for a species that is about to wake up. There is a final, unresolved dread in the latest reports. The rotation period is not just stable, it is slowing down at a rate of 1/1000th of a second per day. This is the final dread note. It means the object is coming to a halt. It is arriving at its destination. And that destination is not a point in space, but a point in time. Share your thoughts below on what you think the activation truly signifies. Are we witnessing a beginning or an end? Or perhaps we are just witnessing a rotation that has nothing to do with us at all. We may already be part of the experiment. Close your eyes. Listen to the clock on your wall. Is it ticking or is it counting down? The night is long and the traveler is still turning. The history of Japanese astronomy is a long corridor of meticulous records. And if we look back to the 17th century, there are descriptions of guest stars that behaved with a similar, haunting regularity. 3I Atlas seems to be a reincarnation of these ancient anomalies, a bridge between the Edo period's wonder and our current technological paranoia. On December 19, 2025, a collaborative study between the European Space Agency and the Japan Aerospace Exploration Agency revealed that the object's surface is not composed of the usual silicates, but a carbon-based lattice that absorbs 99% of all incoming light. This explains the mystery of the rotation period. We aren't seeing the rock spin, we are seeing the light reflect off specific, intentional facets. Imagine a diamond the size of a city, turning slowly in the dark, reflecting the sun only when it wants to be seen. There are 3 primary conspiracies circulating in the fringe journals: that it is a relativistic probe, a discarded fuel casing from a Type 2 civilization, or a navigational marker left for someone else entirely. The mythic connection here is the Star of the Weaver, a celestial coordinate that was said to guide the souls of the ancestors back to the root country. You might find it hard to believe that a simple piece of space debris could hold such weight, but the math does not lie. By January 5th, 2026, the trajectory showed a micro-adjustment that bypassed the gravity well of Mars with a precision of 6 decimal places. Unfortunate timing for those who believe in a random universe. Those 2 words are doing a lot of work in the latest peer-reviewed papers. Share your thoughts below on whether you believe space is truly empty, or if we are simply the latest tenants in a very old building. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand the Star of the Weaver, we must look at the Tanabata legend, a story of 2 lovers separated by the Milky Way, permitted to meet only once a year. In the traditional Japanese calendar, this intersection of celestial bodies is a moment of profound alignment. When the National Astronomical Observatory of Japan analyzed the rotation of 3I Atlas, they found that its axis is pointed directly toward the star, Vega, the Weaver Girl, with a deviation of less than 1 arcsecond. This is not the behavior of a wandering rock. It is a locked bearing. It is a cosmic compass that has been set to a specific frequency, a fixed point in the heavens that has guided travelers for millennia. Imagine the ancient navigators, the people who lived before the invention of the telescope, who looked at the sky not as a void, but as a map. They spoke of the root country, a place of origin, an ancestral home located beyond the visible horizon of the stars. If 3I Atlas is indeed a vehicle of memory, as some scholars now suggest, then its rotation period is the pulse of that memory, 8 minutes and 42 seconds. It is a slow, rhythmic repetition that echoes the ancient chants used in Shinto rituals to call back the spirits of the departed. The precision of the trajectory adjustment on January 5th was so refined that it suggests a conscious avoidance of Martian debris fields. A rock does not dodge obstacles. A rock does not correct its course to maintain a view of a specific star. Dr. Avi Loeb has famously proposed that the universe is likely littered with the technological bottles of civilizations that have long since vanished. If 3I Atlas is such a bottle, the message inside is not written in ink, but in the very fabric of its motion. By mid-January 2026, infrared scans from the James Webb Space Telescope revealed a series of etched patterns beneath the surface crust of the object. These are not geological fissures. They are geometric arrays, repeating 7s and 3s, the sacred numbers of the Babylonian and Sumerian star watchers. The mythic resonance is undeniable. We are looking at a return cycle. In ancient Mesopotamia, the gods were said to return to Earth every 3,600 years to inspect the progress of their creation. The timing of 3I Atlas, arriving exactly as our own surveillance capabilities reached their peak, feels less like a coincidence and more like an observation. There is a certain dry irony in the way the scientific establishment handles these revelations. They speak of optical anomalies and speculative correlations, but in the private journals of the lead researchers, the tone is one of hushed reverence, unfortunate timing. Those words doing a lot of work. If we acknowledge that this object is following a mythic blueprint, we must also acknowledge that our history is not what we think it is. We are not the first to see the Weaver's star. We are simply the first to measure its rotation to the 9th decimal place. You might think that our modern technology makes us superior to the ancients, but here is why you are wrong. The ancients didn't need a telescope to know that something was coming. They lived in harmony with the cycles. They understood that the sky is a clock, and that every few thousand years, the hand of that clock returns to the starting position. Let us consider the 3 primary conspiracies that have emerged regarding the mythic origin of 3I Atlas. The first is the ancestral beacon theory, which posits that the object is a repository of genetic information, a backup drive for the human race sent by a progenitor civilization. The second is the celestial boundary hypothesis, suggesting the object is a marker that defines the limits of our planetary influence, a keep-out sign placed by an older power. The third, and most unsettling, is the recursive history theory, the idea that 3I, Atlas is us, sent back from the distant future to ensure that we do not stray from the path that leads to its own creation. Each of these theories relies on the same mathematical foundation, the 8-minute and 42-second rotation period. It is the key that unlocks the door to a history we have forgotten. As you listen to the low, humming narrative of this discovery, let the vowels stretch out like the vast distances between the stars. The M of the marrow, the L of the weaver, the S of the silence. These are the sounds of the deep night. The Japanese scientists have clarified the rotation, but the clarification has only deepened the shadow. They found that the light reflecting off 3I Atlas carries a spectral signature that matches no known element in our periodic table. It is a substance that exists in a state of ordered chaos, shifting its density in response to the magnetic field of the sun. This is the activation. This is the moment the machine begins to breathe. By January 20th, 2026, the object had reached a position in the solar system where it began to interact with the solar wind in a way that produced a low-frequency hum. This hum, when recorded and sped up, mimics the sound of a human heartbeat. Not a frantic heart, but a calm, steady one. The heart of a traveler who knows exactly how much further they have to go. The mythic connection to the Star of the Weaver suggests that the destination is not here, but beyond. We are merely a waypoint, a rest stop on a journey that spans the galaxy. This realization is heavy, but it is also liberating. It means we are not alone in the dark. It means there is a map, even if we cannot read all the symbols yet. Now, you could argue that we are imposing our own stories onto a cold, indifferent piece of space matter. But why then does the math align so perfectly with the myths? Why does the trajectory bypass Mars with such deliberate grace? The pseudo-academic citations from institutions like the National Astronomical Observatory of Japan serve to ground these wonders in reality. When they say the rotation is corrected for gravitational perturbations, they are admitting that something is steering. When they say the brightness variations are statistically improbable for a natural body, they are admitting that we are looking at an artifact. The FOMO hooks of the modern world tell us we must see everything, know everything, record everything. But 3I Atlas reminds us that some things are meant to be felt, not just seen. In just over 4 weeks, the object will cross the heliopause and vanish into the interstellar medium. We won't be able to see it again until the next cycle, long after our cities have crumbled and our names have been forgotten. This is the scarcity of information. This is the ultimate cliffhanger. We have been given a glimpse of the Weaver's star, and then the curtain is drawn. Think about the root country. In Japanese folklore, it is a place of shadows and secrets, but also a place of rebirth. If 3i Atlas is returning there, what is it taking with it? Is it carrying the data of our existence, the sum total of our triumphs and our failures? Or is it simply a piece of hardware returning to the dock for a scheduled maintenance? The irony of our curiosity is that we want to be the center of the story, but the story of 3i Atlas began billions of years ago, and we are just a footnote in one of its later chapters. The countdown is ticking, the rotation is steady, the Weaver's star is waiting. As you drift towards sleep, let the rhythm of the 8-minute pulse become the rhythm of your own thoughts. There is no need for answers tonight. There is only the evidence. There is only the pattern. There is only the vast, silent beauty of a universe that is far more organized than we ever dared to imagine. The Japanese scientists have clarified the rotation. They have given us the numbers, but the meaning is something you must find in the quiet spaces between the ticks of the clock. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. The star of the Weaver remains fixed. The traveler moves on. The root country calls, and we, the tenants of this very old building, are left to wonder who else is living in the other rooms. But that was only one theory. There is another, one buried even deeper in time. Let us go further.
Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old reliable law, looked like it had lost its grip. You picture the room where it happened, laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads: statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place. A mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice, numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars, and Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity, catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash, and when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like Well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge. Triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. "Then don't say it out loud." Three-Eye Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3-Eye Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3-Eye Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter. self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy. Another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas web pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the web. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas web had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it "not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable. Instrumental interference, but even interference doesn't keep time this perfectly. One data analyst described it best. If this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3I Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums. Something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity, catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something, a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing, a glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional. The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like Well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines, Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first.
The great silence. The sun begins to rise over the Pacific, turning the horizon into a thin line of bruised purple and gold. But the sensors at the Kamioka Observatory remain dark. 3i Atlas has vanished from the light curve entirely. There is no explosion, no flash of light, and no physical debris. It has simply ceased to be observed. Let me back up to the choice point of Act 8. We felt a sense of dread as the object accelerated toward its perihelion, fearing a collision or a conquest. But the conquest was of a different nature. It was a conquest of our attention. By drawing our eyes to the heavens, 3i Atlas performed a planetary-scale intervention. It reminded us that we are a single biological unit, a lab culture that is capable of great wonder when faced with the infinite. The final act is not one of noise, because noise is the tool of the small-minded. The return of the original state is the return of a perspective that sees the galaxy as a home rather than a frontier. The object didn't need to change our world. It only needed to change the way we look at it. There is a pseudo-academic comfort in the official reports from Dr. Jacqueline McClary and her colleagues, who characterized the disappearance of 3I Atlas as a unique observational anomaly likely involving dark matter interaction. It is a safe, clinical way to close the book. But in the late night hours, over low-frequency transmissions and whispered conversations, the real interpretation remains. The object didn't disappear. It moved into the great silence where it has always resided. It moved back into the gaps between our thoughts, into the spaces between our atoms. It is still here, a silver ghost in a titanium mirror, watching us through the very instruments we use to track it. The warning that was missed has become a promise that was kept. The promise that the universe is far more complex, far more ancient, and far more intimate than our calculators could ever suggest. The light curve was a status report for a someone else, yes, but perhaps that someone else is the version of humanity that will exist 12,000 years from now when the cycle returns again. We are the ancestors of the next transition. We are the ones who will leave the static for the next generation to decode. The data is archived, not for our scientists, but for our descendants. It is a message in a bottle, thrown into the ocean of deep time. I want you to feel the stillness of this final act. The long form, slow burn of the last few months has led us to this moment of absolute rest. There is no more tension. There is no more suspense. There is only the steady, hypnotic rhythm of the Earth spinning on its axis, carrying you through the dark toward a tomorrow that is exactly like today, yet fundamentally transformed. The subdued paranoia has evaporated, replaced by a warm, compassionate awareness of your own place in the pattern. You are a passenger on a blue marble, and for a short time, you shared the sky with a traveler from the beginning of time. The ritualized listening experience is coming to a close. The loop is complete. The countdown has hit 0, and the universe has answered with a peace that surpasses understanding. You are no longer just a listener. You are the resolution of the mystery. You are the human reflection that the silver facets of 3I Atlas came to see. And as you drift into the orbit of tomorrow, you carry that light within you. It is a light that doesn't flicker. It is a light that doesn't dim. It is the original state of the universe, waking up inside your own heart. Close your eyes. Feel the weight of the atmosphere protecting you. Feel the slow, heavy pulse of the planet beneath you. The vigil is over. The guest has departed. The house is quiet. And you are safe. The great silence is not a void. It is a home. It is the place where all the signals go when they are finally understood. It is the place where the light curve becomes a straight line, leading you into the deep, dark, and beautiful unknown. The interpretation is finished. The story is yours to keep. Let the silence guide you. Let the shadows hold you. Let the memory of the silver light wash over you like a gentle tide. You are a part of the orbit now. You are a part of the tomorrow that 3I Atlas has already seen. Close your eyes and drift with the orbit of tomorrow. Drift into the silence. drift into the light. The vigil is complete.